Hey everyone. I wanted to try this and then see how I felt. I'm already not sure, but I thought it could be interesting. So I'm going to do it anyways. So here we are. Our objective, or my objective for this video lesson, what I want you to get out of this is I want you to use what you know about functions, right? And what you know about function properties. You know some of that, and we've reviewed some. And just the number system in general and things that work and what you can do with it. And so use like what we've reviewed to essentially analyze functions and identify any domain restrictions, right? So we've looked at domains and range like when you're on a graph and you're physically seeing it. But what if like algebraically you have to determine what the domain is and what do we need to kick anything out of the domain? Does it exist everywhere? So this is more algebraic. Whereas what you've done before is graphic. There will be some graphical thing or like graphing things that I bring into this because I do think it is very good to be able to visualize what you're working with. And if you have an understanding of what a function looks like, it's going to help you to get the algebraic idea of, well, what am I getting rid of in the domain? But we are not picking these up. So I have mine next to me, but we're not using it. So I'm going to put it away. There, now it's away. It's out of reach. Amazing. Okay. So function notation. So this is an important one that I do want to begin with. So y is the same thing as f of x. You're only going to use f of x, and I'm only going to use f of x. Anyone is only going to use f of x if we're actually dealing with a function. Right? I'm not going to use f of x and then say, is f of x a function? Like, I shouldn't be calling it f of x if it's not a function. Right? So it's read f of x. It's not f times x, it's f of x. It's just called function notation. It means to find the function whose name is f, whose independent value is x. Right? So you could see something like g of x, h of x, k of x, m of x, n of x. Like it's whatever the name of the function is what we're using there. F of x is just common. F of x is the value of the function at each value of x. So f of x is the dependent variable. X is the independent variable, right? So we control what we're substituting in. F of x is the outcome. So for instance, f of x equals 2x plus 3. The domain of this, well, what is this? It's a line, right? Like think about it visually. So this is going to be true with any diagonal line. Sorry. Oh man, I clicked too much. It's going to be all real numbers, so I can use the all real number symbol. Ooh, we learned that. Or I could say something like negative infinity to infinity. Right? And as you've spoken about before, or as you've looked at a little bit, these brackets are here because infinity represents that something just keeps getting bigger, something keeps getting smaller. It's not a number. It's not inclusive. It just keeps growing. You never actually get to infinity. It's massive, or really, really small. Okay, so to determine the domain of a function without a calculator, assume all real numbers, right? As we have said in IB and just in general, if it doesn't specify which number system you're working in, if it doesn't say the set of complex numbers, if it doesn't say find all real and imaginary, if it doesn't say that your set is natural numbers, if it doesn't say any of that, you're going to assume that it's the real number system. So operate with the idea that it is the real number system, and that's true in calculus, that's true in IB, like that's really like where we're operating. You're usually working in the real number system, so it's fair to assume it. Do you have any what I'm going to refer to as domain busters? Do we have anything that's just not allowed is what you want to think through? Can't divide by 0. Ooh, you can't see my thumb. You can't take the square root of a negative, right? We're working in the real number system. Those things are like no-nos, like we can't do that. That's all for now. There'll be more things that you can't do later. Determine what values create these domain busters. Which values do this? What value is going to cause you to divide by a 0? Which value is going to cause you to have a negative under your radical? Kick them out. Those have to leave our domain. So eliminate those from the domain. So this first one, I think I'm a little in the way. Can I go over here in the corner? Can I get smaller? Oh, I can get little. This is so cool. I don't know actually if it's cool. You guys are probably like, this is weird. To determine the domain of g of x equals the square root of 4x minus 2. Is it all real numbers? Can x be anything? No, right? Oh, can't take the square root of a negative. Right? That's one of the domain busters. What values of x create those negative numbers? Well, what's going to make this negative? Well, let's figure out what makes it 0. Right? Let's take that and let's set it equal to 0. What do you get for x when you solve this? Add 2, and you're going to get 4x equals 2. X equals 1/2, right? That's what's going to cause f of x. When x is 1/2, g of x will be 0. Okay? Think about a number line. This point right here, I'm going to call 1/2. This is 0. This is like a height of 0 is what I'm getting at. Well, if you just look at, oh, there's my 1/2. If you just look at 4x minus 2, and I told you to graph that, that's an increasing line. Here's where it's not allowed. Here's where it's allowed. This is, no, this is yes. Right? So what has to be true? Well, my domain is going to be that x has to be greater than or equal to 1/2. That is my domain. Right? I'm getting this line because I'm narrowing it. I'm not even paying attention to the radical. The radical was what told us we can't have negative numbers. And I just focused in on what was under that radical. Because that's where that line is. It can equal to 0. It just can't be less than 0. The other way you could write this is 1/2 to infinity. If you want to write, this is called interval notation. Those of you that are taking notes, all of you. Right? Either one is the same representation. This means that it includes that 1/2. Amazing. Okay, let's look at another one. So similar idea, right? We've got a radical. Not all real numbers, right? X can't be x plus 10 cannot be negative. So we've got to figure out, well, where is x plus 10 equal to 0? Where x equals negative 10. I'm going to do that number line again. And maybe you don't need it, but I'm going to show you why I'm doing it, because at some point it's going to be helpful. It's not always going to be linear. Take that number line. This will be negative 10. It can equal to negative 10. And it can be, it's an increasing line because it's a positive slope. Can't be down here. This is no, this is yes. So my domain is x is greater than or equal to 10, or interval notation, negative 10. Sorry, that's a negative 10. To infinity. Right? One of these is an appropriate way to represent this. Okay, so those first two, 4 and 5, are pretty similar. Oh, okay, we can do this. Is this all real numbers? No. X squared plus 7x plus 10 has to be 0 or greater, right? It has to be greater than or equal to 0. So what values of x create negative numbers? Create a negative under that radical. So let's take x squared plus 7x plus 10 and set it equal to 0. What are you going to have to do? Aren't you going to have to factor? This is a quadratic. Right? So this is why we're not factoring for the fun of factoring, even though it's fun. We're factoring because we need it. We need it to figure out the domain of this square root function. How crazy. So factor it. X plus 5, x plus 2 equals 0. The 0 product property tells me x plus 5 equals 0 and x plus 2 equals 0. So x equals negative 5 and x equals negative 2. Right? So I'm going to break out that number line. Check this out. I'm going to have 2 spaces here. I should probably go from least to greatest. It's a number line. It can equal to this line, right? It can equal to 0. This will be negative 5, and that will be negative 2. But then I want you to think about, well, what does this look like? This is a parabola. It's quadratic. And which way is it going to open? Up, right? Your leading coefficient, A, the coefficient in front of your squared term, your highest exponent, is positive. So it's going to open up. Remember, this has to be greater than or equal to 0, so it's got to be above this line. So this is fine. Ooh, not so fine, not so fine, not so fine. And fine. Right? This not allowed, this allowed, and this allowed. So let's talk about the different ways we can do that, right? So this is where that number line becomes pretty useful, right? You got to think about, well, what's happening on either end of those zeros and what's happening between them. And a visual picture like this is helpful. Okay, so I can say for the domain, I can say x is less than or equal to -5, or x is greater than or equal to -2. That's one way I could say it. I could also say -infinity to -5 inclusive union, right? This means like or. This means or. Union is or. -2 to infinity. Right? Those are probably the two ways I would represent it. Again, this is interval notation. I like interval notation. Whoa. This one doesn't have a radical. Must be all real numbers, right? No. I like frozen the screen for a second and looked kind of crazy. So not all real numbers because you can't divide by 0. So which values of x create 0 in that denominator? So I'm going to take that denominator and I'm going to set it equal to 0. Right? So let's see. Oh, there you go again. Here's a quadratic, and I'm going to have to factor. So let's see. X plus 5, x minus 2 equals 0. 0 product property allows me to say x can equal -5. X equals 2. What happens? Do you think I should do that number line? Oh, darn. I didn't mean to click. I thought I had one more thing that was going to come up. Let me recreate that. What were, no, I won't. I'll just say what they were. What was it? X equals 5, -5, and x equals 2, right? Yeah, because I had x plus 5, x minus 2. When I did the 0 product property, I got these two. So this can be positive. This can be negative. It just can't be 0. So my domain is going to be all real numbers except for those, right? You can say all real numbers, but x doesn't equal -5 and 2. There's so many different ways you can use. I can write this as an interval and say it's going to be from -infinity to -5, not including it, union -5 to 2, not including it, union 2 to infinity. Right? That works too, but I want to make sure, like, if I were to do the number line and I had -5 and I had 2, these are going to be open circles because it can't equal to it. And then this is fine. This is fine. This is fine. These dots are not fine. Right? So just make sure you're thinking through, like, and you're not just saying, I always need to do this line. I always need, it can't be greater than or equal to 0. It can't be less than, like, you have to look at the problem and think through, well, I'm dividing and I can't divide by 0. Well, I'm taking the square root and I can't take the square root of a negative. Or I'm doing both. This can't be negative and it can't be 0. Right? Think through it. There's not like a, here's the simple step-by-step instructions. You've got to think about the problem that you have in front of you. So this one's clearly not all real numbers. You've got to figure out what makes this 0, right? Our approach is going to be the same, that we need to remember that this cannot be 0 or less. 0 is going to be kicked out of our domain too, so which is not inclusive, right? And the reason for that is because you're dividing and you can't divide by 0. It's not because you can't divide by a negative. The negative piece is because you can't take the square root of a negative. So what values of x create 0 and create negative numbers? I'm going to take that, and I'm going to set it equal to 0, and we did this one, didn't we? We factored this in our last slide, and we said it was x plus 5, x minus 2, and we got that x equals negative 5 and x equals 2. I do want a number line for this, and I'm going to stick negative 5 and 2 there, and guess what? These are going to be open circles because they're not allowed. They're not inclusive. This is, again, a parabola that opens up. That's okay. This is not okay. That's negative. That won't work here. This is okay. So if I want the domain of this, I would have to say something like x is less than negative 5, not equal to, or x is greater than 2, not equal to. If I wanted to do interval notation, I'm going to say negative infinity to negative 5, not inclusive, union 2 to infinity, not inclusive of anything. Right, so you've really, there's not a one-stop, this is what you always have to do. You've got to look at the problem and use some of your background skills and what you know about what you know that you're not able to do, what numbers don't let you do. So we're going to do a few more. What about this one? Should I set it equal to 0 and see what happens? No, that's so silly. It's a quadratic, right? So this is what I'm trying to get at is don't look at it and be like, every single time I need to set it equal to 0 and figure out what happens and kick it out of the domain. Look at it. This is just a quadratic. We know that for quadratics, for a parabola, a U that opens up, that's my favorite letter. It's not going, it's not gonna, I don't need to analyze where this is equal to 0, right? It's just all real numbers, or negative infinity to infinity. That is the domain. Amazing. Okay. So if you haven't paused the video to try on any on your own, try these two. And when you're ready to go over them, unpause them, and I'm going to go over them. So h of x, okay, I'm taking the square root, so this cannot be negative. So I want x squared plus x minus 12 to be greater than or equal to 0. It gets a little weird when I try to factor and do something with this. So I'm just going to figure out where it is 0. So I'm going to have to factor x plus 4, x minus 3. So it's going to be 0 at x equals negative 4 and x equals 3. But it's allowed to be 0. So I'm going to draw the line. And I like to really draw it, especially when I'm dealing with a quadratic. Right? When I'm saying a quadratic, what's under the radical is a quadratic. So I'm going to stick my negative 4 and I'm going to stick my 3. It can equal to 0, so I'm going to immediately just put these dots here. Is my quadratic, does it have a positive leading coefficient? It does. So it's going to open up. It can't be negative, right? That's what we led into it with. So my domain, and notice what all my work looks like. I hope you guys do this too. X is less than or equal to negative 4. Or x is greater than or equal to 3. Interval notation, again, is negative infinity to negative 4, including it, union 3 to infinity. Union means or. Just look how fancy that one looks, though. So hopefully that one worked out for you. This one. Does what's in the numerator matter? No, we're good, right? We don't have any restrictions or domain busters or limitations or whatever you want to call them from this numerator. Right? It's 5x. I can do anything with that. My restrictions are to come down here. Well, I'm dividing, so it can't be 0. And I'm taking the square root, so it can't be negative. So let's figure out, so we want 3 minus x times 4 plus x to be greater than 0. So let's figure out where it is 0. Right? It's, again, going to get a little messy if I try to just do that. So this is nice. It's already factored. 3 minus x equals 0, and 4 plus x equals 0. So this, if I go to solve it, I'm going to get x is positive 3, and x is negative 4. So I'm going to go ahead and draw my nice number line. Again, this is quadratic, right? I have two x's. It's an x squared. It's already in factored form. So I'll put it in order. This will be -4 and this will be 3. And I'm going to go back up here and I'm going to say, does this open up or down? Is this a positive leading coefficient or a negative leading coefficient? Well, let's focus in. If I were to multiply it out, I have a negative x and a positive x. It's going to be negative. It's going to open down. My computer's struggling. I'm almost there. So it can't equal these because it can't equal to 0 because of that division. It can't be this. Whoa. It can be that. Can't be this. Right? Now this is okay, but these aren't. That's where that opens up versus opens down is important. And that's why I'm so big into this visual picture of it. So the domain for this one, I'm going to say -4 is less than x is less than 3, right? It's not equal to. Or I can write it as an interval and say, that's a parenthesis, -4, 3, right? That's interval notation for this. That's saying it's going from -4 to 3. You guys have more practice on this. There are support worksheets on there. There's a worksheet and an answer key for you, as well as some Delta math practice that I encourage you to log in and practice and try. And keep in mind that you have a quiz during our next live session. So if you feel you need more help or more practice and more support with this, that's completely acceptable. But I would encourage you then to attend Wednesday's session and reach out to your teacher. That's a great place to review and make sure that you get these concepts. So we hope to see you there. Thanks for watching, everyone.